On page 320, the chapter then shifts to a description of cognitive control, or executive function, and the influence that this has on sentence processing. The principle of cognitive control is just a property that we have in the brain. Some have it more than others, but it allows us to focus on something we're trying to keep our attention directed to, and to ignore distractors that might draw our attention away from it. It allows us to switch quickly also between different kinds of things that we're supposed to be focusing on, and not to get fixated on one thing, and rather than, and I guess, to not be able to move our attention from one thing to another. So the chapter describes then how this might be able to play into sentence processing. The left inferior frontal gyrus, it's an area of your brain, sort of like if you were to touch your temple, the temple of your head, it would be, of course, on your left side, and it would be just right under the surface of the skull there. It's a gyrus that is, a gyrus is like a bump in the brain, one of those, as you see on the skull, you see the wrinkles all over the brain. One of those lumps is a gyrus, and so that the lump that's in the brain right underneath your temple on the left side is the left inferior frontal gyrus. And that gyrus seems to be the area of the brain that mediates executive control or executive function or cognitive control, and it seems to be that brain area seems to be activated when performing different kinds of tasks, like the Stroop test, and there are other kinds of cognitive control tasks, but if you allow somebody to perform the Stroop task, that's one of the most difficult and most reliable that we've seen. The Stroop task is presented there in the text, and you've probably heard of it before. It's a task where a word is written, but the font of the color of the font is incongruent with the word that's printed. So, for instance, there in the text you can see the word yellow is printed in a font that is red in color. And the goal is to say the color, not the word. So if you were to read through a list of these, you would have to say the color of the font and inhibit your desire, your natural inclination to say the word and ignore the color of the font. In order to perform the Stroop task, that obviously the point is that the Stroop task is requiring the left inferior frontal gyrus, and that is a test of executive control. People who are better at the Stroop task are also better at certain linguistic processing skills. For instance, we move to box 8.5 and we see that people who are bilingual are better at the Stroop task. They're also better at this Simon task, which is to shift your attention from a box that's flashing on one side of the screen to another side of the screen, and depending on the color of the box, you have to hit a key that's on the right or the left side of your keyboard. But when the box is on one side of the screen and you're supposed to pay attention not to the location of the box but to the color of the box, that makes it difficult spatially when you're trying to push a key on the keyboard that's incongruent with the side of the keyboard is incongruent with the side that the box is appearing on. So that requires cognitive control in much the same way that the Stroop task requires cognitive control. We want to pay attention to the spatial location of the box, not the color, but we're being required because of the task to pay attention to something that we're not inclined to pay attention to. But people who are bilingual have better cognitive control, and people who have better cognitive control are also better at linguistic processing tasks. Young children don't have good cognitive control. Their frontal lobes are not yet developed. And because of that, they aren't able to inhibit certain behaviors. One of the things they can't inhibit is a natural inclination to process garden path sentences in the wrong way. Once a sentence part has been processed the incorrect way, children aren't able to go back and fix their understanding of that sentence. An example here is on page 323. You can see the picture there, the figure 8.9. On this figure, when researchers tell children, let's see, where's the sentence? Put the frog on the napkin into the box. What they're saying is, if the frog is on the napkin, that's the frog they're talking about. Put the frog on the napkin in the box. But because it's a garden path sentence, our inclination is at first to say, put the frog on the napkin. And so children will take the frog and put it on the napkin. And in fact, because they hear both commands, they hear put the frog on the napkin in the box, they'll jump the frog, they'll hop it from the napkin that's onto the other napkin, then into the box. And the reason they do that is because they can't inhibit, they don't have a developed LIFG, so they can't inhibit, with their cognitive control, the first interpretation of the sentence that they originally had, which was that the frog needed to be put on the napkin. And so they sort of combine the information that was really a modifier about the frog on the napkin. That modifier, they incorporate that into the directions, so that they will follow both the modifier and the direction itself. If they were to perform the task correctly, they would just put the frog directly into the box. But instead, they hop the frog from the napkin it's on to the other napkin, then into the box. And that's pretty much all I wanted to share from the chapter. Those are the most important parts. If you understand those things, you'll probably do very well on the test. Take care.